Hello friends, I welcome you in lecture number 29 on graph theory. In this lecture also we will discuss one more question on isomorphic graphs. Now we are familiar with isomorphic graphs and we have discussed how to check whether two graphs are isomorphic or not in previous two lectures. So here also we will see or we will determine whether these two graphs are isomorphic or not, and this question was asked in GTU Summer 2022 exam. Now what is our criteria is, first we determine the number of vertices and number of edges in both the graphs, and we check whether they are equal or not. So you can see from these two graphs, here we have vertices starting from u1 and ending up to u6, and same thing here, they are denoted by v1, v2, v3 up to v6. That means both the graphs have same number of vertices, that is 6. And number of edges are in graph G, we can count 1, 2, 3, 4 and 5 edges are there in graph G. And in graph H also we can see 1, 2, 3, 4 and 5 edges. So there are equal number of vertices and equal number of edges in both the graphs. Now we can check for degrees of vertices for both the graphs. We first start with graph G. Here u1 is incident with only one edge, that is degree of u1 is 1. u2 is incident with two edges, therefore degree of u2 is 2. u3 has also degree 2. And u4 is incident with 3 edges, therefore degree of u3 is 3. u5 is an incident with only one edge, therefore degree of u5 is 1. And similarly degree of u6 is also 1. Here degree of v1 is 1, degree of v2 is 2, degree of v3 is 3. There are 3 edges meeting at v3, and there are 2 edges meeting at v4, therefore degree of v4 is 2. And there is only one edge incident with v5, therefore degree of v5 is 1. And same thing for v6. Now we can see that in graph G we have u1, then u5 and u6. These three vertices are of degree 1, or there are 3 vertices of degree 1 in graph G. So here also we must have 3 vertices of degree 1, and those are v1, v5 and v6. And what about vertices of degree 2 in graph G? So they are u2 and u3. And here vertices of degree 2 are v2 and v4. And what about vertices of degree 3? So there is only one vertex of degree 3 here, which is u4, and here also there is only one vertex of degree 3, which is v3. So we can compare here, we have 3 vertices of degree 1, same thing here. Here also we have 3 vertices of degree 1. In graph G there are 2 vertices of degree 2. So here also there are 2 vertices of degree 2, and both the graphs have 1 vertices of degree 3. So this gives us the idea that there is a chance that these graphs can be isomorphic. So we can try to define isomorphism or function from vertex set of this graph to the vertex set of this graph. But another care we have to take is that suppose here degree of u2 is 2 and u2 is adjacent with u1 and u3. Degree of u2 is 2 and u2 is adjacent with u1 and u3. Degree of u1 is 1 and degree of u3 is 2. So image of u2 will be that vertex from H whose degree is 2 and it is adjacent with vertices of degree 1 and 2. So here there are two vertices of degree 2, v2 and v4, and if we check for v2 say, then v2 is adjacent with v1 and v3. So v2 cannot be the image of u2 because u2 is adjacent with u1 and u3, which are vertices of degree 1 and 2, and here v2 is of degree 2, but v2 is adjacent with v1 and v3 and degree of v3 is 3. So we cannot consider image of u2 as v2. Now if we check for v4, then v4 is also adjacent with v5 and v3, which are vertices of degree 1 and 3. So v4 can also not be an image of u2. So it is not possible to define isomorphism which satisfies adjacency relationship here. We can check for vertices of degree 1 also. Here we can see that u1 is vertex of degree 1 and u1 is adjacent with u2 only. u1 is adjacent with u2, and what is degree of u2? It is 2. Then u5 is adjacent with u4 and degree of u4 is 3, and u6 is also adjacent with u4 and degree of u4 is 3. This is for first degree vertices of graph G, and first degree vertices of graph H are v1, v5 and v6, and we check that v1 is adjacent with v2 and degree of v2 is 2. v5 is adjacent with v4 and degree of v4 is 2. And v5 is v5 we have seen, and we have to write v6 here. v6 is adjacent with v3, degree of v3 is 3. Now if there is some isomorphism, then we know that if we have degree 1 vertex in graph G, then its image must be degree 1 vertex in another graph. Similarly, if this vertex is adjacent with a vertex of degree 2, then its image must be adjacent with vertex of degree 2 only. Now you can see here that if I consider image of u1 as v1 or v5, suppose I consider image of u1 as v1, then here u1 is adjacent with vertex of degree 2, so here also v1 is adjacent with vertex of degree 2, so this will work. But here for u5 also, if we consider image of u5 as v6, then u5 is adjacent with vertex of degree 3, so here also v6 is adjacent with vertex of degree 3. But for u6 we have the vertex adjacent is of degree 3, but here the vertex adjacent with v5 is not of degree 3. So here also there will be a problem to define isomorphism. If such isomorphism exists, then if we have vertex adjacent with vertex of degree 3, then here also we have the vertex which is adjacent with vertex of degree 3. So we have seen that there is a problem in defining an isomorphism in such a way that adjacency relationship is satisfied. Therefore, these two graphs are not isomorphic.